alaikum wa rahmatullah. We will start this academic year by a lesson which you already have an idea about it in grade 9, which is oxidation and reduction. The objectives at the end of this period, you will be able to define the different terms used in oxidation and reduction, write the oxidation and reduction half equations, deduce the overall equation, and write the redox couple of oxidation reduction. The materials needed during this period are a pen and a notebook to write your notes, and a worksheet which you are supplied with that includes the main ideas and terms mentioned in the video. Have you ever seen a rusted nail, spoiled food, or burning wood? Almost 1/3 of chemical reactions taking place around us are some form of oxidation reduction reaction. In grade 9, if you remember, oxidation reduction reactions are simply abbreviated by redox reaction. What is an oxidation reduction reaction? In oxidation reduction reactions, electrons move between atoms. As you can see here, an electron moves from A to B. First, we have to talk about a reaction between a metal and a metal ion. We are going to perform an experiment about this idea. The objective of this experiment is to interpret the reaction between a metal and a metal ion. Materials needed during this experiment are a copper wire and a silver nitrate solution and a beaker. The procedure of this experiment. First, we have to dip the copper wire in a silver nitrate solution, as you can see in this figure. What is the color of the copper wire? It is brown. And what is the color of the silver nitrate solution? It is colorless. Now we have to leave the solution for some time. Let's observe the figures. As you can see, the copper wire is now covered by a white bright deposit. Is there any change that you can notice between the beginning of the experiment and at the end of this experiment? Yes, of course, it is a change in the color of the solution. The solution becomes blue. It is also important to note that this reaction is accompanied by an increase in temperature. Then we can say that it is an exothermic reaction. Qualitative study of the reaction. Let's observe the adjacent figure, then we have to answer the following questions. This figure represents what happened in the previous experiment, which was between a copper, when we dipped a copper wire in a silver nitrate solution. As you can see, a white deposit formed on the copper wire, and the color of the solution turned into blue. The first question is, at the beginning of the experiment, copper and silver exist in which form? CO2 plus and Ag, Cu and Ag plus, CO2 plus and Ag plus. Since copper is a metal, then at the beginning of the experiment, it exists in the form of Cu. And since silver is found in the solution, then it is found as an ion, which is Ag plus. Then the answer will be Cu and Ag plus. Another question. The white deposit at the end of the experiment indicates the presence of course, it is Ag. 3. The blue color of the solution at the end of the experiment indicates the presence of Ag plus, Zn2 plus, or CO2 plus. We all know that the blue color is due to the presence of copper 2 ions CO2 plus in the solution. The results above indicate that two transformations took place. In order to know what are these transformations, let's complete these two half reactions. The first half reaction, Ag plus how many electrons? Since Ag plus has only one positive charge, then it needs one electron. Ag plus 1 electron will give Ag. And in the second transformation, something gives CO2 plus. What gave CO2 plus? It was Cu. Cu, in order to become Cu2 plus, it has to lose 2 electrons. In equation 1, is there gain of electrons or loss of electrons? Look at the electrons in equation 1. They are at the reactants, then we say that there is gain of electrons. In equation 2, since the electrons are found in the products, then we say that there is loss of electrons. And if reduction half reaction occurs in case of gain of electrons and oxidation half reaction in case of loss of electrons, let's assign the type of each half reaction 1 and 2. Equation 1, which was Ag plus 1 electron, gives Ag. Since there is gain of electrons, then we say that this is a reduction half reaction. While in equation 2, Cu gives Cu2 plus 2 electrons. Since there is loss of electrons, then this is an oxidation half reaction. We can memorize oxidation and reduction by using the terms Leo says Gr. Leo, which is an abbreviation for loss of electrons, means oxidation. Loss of electrons means oxidation. And Gr is gain of electrons means reduction. This is how to memorize these two terms. Very important note that oxidation and reduction always occur simultaneously. Simultaneously, it means that they occur at the same time. Overall reaction. How to write an overall reaction? An oxidation is not a complete reaction. Also, a reduction is not a complete reaction. We say oxidation half reaction and a reduction half reaction. The complete reaction, which consists of both oxidation and reduction, is called an overall reaction. If we have to write an overall reaction of two half reactions, first we have to add the two half reactions in order to get the overall equation. Let's look at this example. The oxidation half reaction is Cu gives Cu2 plus 2 electrons. The reduction half reaction is Ag plus 1 electron gives Ag. It is very important to note that the total number of electrons lost should be equal to the total number of electrons gained. Look here, we have here 2 electrons, where in the reduction half reaction we have 1 electron. These electrons must be equal. How to make them equal? We can multiply the reduction half reaction by 2. Then we can get the oxidation half reaction becomes Cu gives Cu2 plus 2 electrons. Nothing changes because we do not multiply it. While the reduction half reaction becomes 2Ag plus 2 electrons gives 2Ag. Now the electrons lost are equal to the electrons gained. Now we can add these two half equations. We simplify the 2 electrons by the 2 electrons gained and lost, and we get the overall equation, which is Cu plus 2Ag plus gives Cu2 plus 2Ag. Terms used in oxidation and reduction. These two terms are very important. First, in a redox reaction, there is transfer of electrons. If the substance gaining electrons undergoes reduction reaction, since it gains electrons, then it undergoes reduction. We can say that this substance which undergoes reduction is called a reduced substance. The reduced substance is the oxidant or the oxidizing agent. Why? Since it undergoes reduction, and then there is an oxidation half reaction which takes place also. This substance that undergoes reduction causes the oxidation of the other substance. It oxidizes the other substance, then we can call it an oxidant or an oxidizing agent. Now, the substance that loses electrons, we know that the loss of electrons means oxidation. The substance that loses electrons undergoes oxidation reaction. then this substance is said to be oxidized. When it is oxidized, it causes the reduction of another substance. Then we call it a reductant or a reducing agent. Example, here an electron moves from A to B. A loses the electron, then B gains the electron. A loses the electron and B gains the electron. Since A loses an electron, then it undergoes oxidation, or we say that it is oxidized. Now B gains the electron, then it undergoes reduction, or it is reduced. A undergoes oxidation, then it is the reducing agent. It caused the reduction of B, while B is the oxidizing agent since it causes the oxidation of A. Another example. Here we have a reaction between copper and silver ions. Cu plus 2Ag plus gives Cu2 plus 2Ag. The question is to assign the oxidant and the reductant in the above redox reaction. First, an electron will move, or the electrons will move from Cu to Ag. Since an electron moves from Cu to Ag, then we can say that Cu loses electrons, then it undergoes oxidation. Since it undergoes oxidation, then it was oxidized by Ag+. Then Ag+ oxidizes Cu. Also, Ag+ undergoes reduction, then it was reduced by Cu. Then we say that Cu reduces Ag+. Then Ag+ is the oxidant since it oxidizes Cu, and Cu is the reductant since it reduces Ag+. Application of what we have taken. If we place a zinc strip, which is silver in color, in a blue solution of copper sulfate, as you can see here. Here we have the zinc strip, which has a silver color, placed in a copper sulfate solution, which is blue in color. Leave it for a few hours. Look, what can we observe? Here there is a brown deposit on the zinc strip, and the color of the solution, it fades. The result, the blue color of the solution fades, as I said now, and the red brownish deposit on the zinc strip appears. The mass of the zinc strip decreases. At the microscopic level, look at the figure. Here, a Zn atom loses 2 electrons. When it loses 2 electrons, it goes to the solution and becomes Zn2 plus ion. These 2 electrons lost by the Zn atom will attract a Cu2 plus ion from the solution. This Cu2 plus ion with the 2 electrons will change into a Cu atom, which will deposit on the zinc strip. Then we can say that Zn and Cu2 plus will give Zn2 plus and Cu. The red deposit indicates the presence of Cu. Since Cu2 plus the electrons lost from Zn, they will form Cu. The decrease in the mass of the Zn strip indicates that Zn changes into Zn2 plus. As we said that Zn will change into Zn2 plus and go to the solution. The two half reactions and the overall equation are: the oxidation half reaction, Zn is going to change into Zn2 plus. It will oxidize to Zn2 plus by losing 2 electrons. The reduction half reaction is Cu2 plus will gain 2 electrons and will form Cu. Now here the electrons are equal. 2 electrons are lost and 2 electrons are gained. Then we do not have to multiply by any number. We add directly, simplify the 2 electrons, then the overall reaction will be Zn plus Cu2 plus in the reactants will give Zn2 plus and Cu in the products. What is the reducing agent and what is the oxidizing agent? The oxidation of reaction is Zn gives Zn2 plus 2 electrons. Then Zn undergoes oxidation, then it is the reducing agent. The reduction half reaction is Cu2 plus 2 electrons gives Cu. Since Cu2 plus undergoes reduction, then it is the oxidizing agent. Another application. If we dip a silver strip in a copper sulfate solution, look at the figure. This is the silver strip and this is the copper sulfate solution, which is blue in color. Leave it for some time and we remove the strip from the solution. Look what happens. The zinc strip does not undergo any change. Also the color of the solution does not change. These are the results. The blue color of the solution doesn't change. The silver strip remains the same. We can say that the silver strip is not attacked by copper sulfate solution. Then no reaction takes place between silver and Cu2 plus and copper sulfate. Indicate whether there is a redox reaction in the figure above or not. Of course, there is no redox reaction. What is a redox couple? In the reaction between Ag plus ions and copper metal, Cu has been oxidized into Cu2 plus. According to the half equation, Cu gives Cu2 plus 2 electrons. Cu undergoes reduction, then we say that it acts as a reducing agent. While in another reaction between Cu2 plus ions and zinc metal, Cu2 plus has been reduced into Cu. According to the half equation, Cu2 plus 2 electrons gives Cu. Since Cu2 plus here undergoes reduction, then it acts as an oxidizing agent. Here, the same element, Cu, acts as a reducing agent, and here it acts as an oxidizing agent. It depends on what? Here, Ag plus. With Ag plus, it acts as a reducing agent. Here, with zinc metal, it acts as an oxidizing agent. Then we can say that the same element can act as a reducing agent, which is oxidized, or as an oxidizing agent, which is reduced, according to the chemical species or depending on the chemical species that are present. Here, Cu2 plus 2 electrons will give Cu, or Cu can give Cu2 plus 2 electrons. Now, the oxidizing agent Cu2 plus and the reducing agent Cu of the same element form a couple, which is called oxidizing agent, reducing agent couple, or we can abbreviate it by redox couple. It is represented by Mn plus M. First, we have to write the oxidizing agent, then we have to write the reducing agent. They are related by the half reaction, which is Mn plus N electrons give M, or M give Mn plus N electrons. Some examples of redox couples are Cu2 plus Cu. The half reaction can be Cu2 plus 2 electrons give Cu, or Cu give Cu2 plus 2 electrons. Another couple is Ag plus Ag. The half reactions can be Ag plus 1 electron give Ag, or Ag gives Ag plus 1 electron. Another example is Zn2 plus Zn. The half reaction can be Zn2 plus 2 electrons give Zn, or Zn gives Zn2 plus 2 electrons. A summary: a redox reaction includes transfer of electrons. If we have two species, A and B, and an electron moves from A to B, A loses the electron, then it undergoes oxidation. B gains an electron, then it undergoes reduction. A is oxidized by B, while B is reduced by A. Then A loses electrons and B gains electrons. Therefore, A is a reducing agent since it undergoes oxidation, and B is an oxidizing agent since it undergoes reduction. And a redox couple is represented by Mn plus. M and its half reaction is Mn plus N electrons give M. The assignment is just to study the definitions in the worksheet. This lesson was prepared by teacher Anfal Yassin. It was recorded by Mr. Mustafa Tlais and supervised by teacher Hiba Badawi. Thanks for your listening.